Hello friends, I am Arvind, and in the last video we have understood the concept called momentum, right? Now in this video, I'm going to start with the Newton's second law of motion, right? I'm actually going to explain this second law of motion in this video only because it's the most important law of dynamics and also it has the equation which is important for both dynamics and classical physics, right? So let's start the second law, right? Second law of motion. Now Newton once he observed and gave a law which says that the net force, this is very important, is proportional to the rate of change, sorry, to the rate of change of momentum. This triangle sign, right? This is called delta. It's a Greek letter, right? Delta. Delta basically means change, right? For example, if you see, right, change in velocity over time is acceleration. So we can write that as delta V by delta T because it's change, right? Here also we can write delta T, right? Because net force is not only proportional, it's basically rate of change means change in time as well. So the time also changes, right? Now for I'll give you an example for the delta thing. Just a minute, right? So now let's say that a person is moving with a velocity of 5 meter per second and finally reaches a point of with a velocity of 10 meter per second. So change in velocity is 10 minus 5, which is 5 meter per second, right? That's it. That's it. You need to understand for delta. Now let's understand what is net force, guys. This is a pretty important concept which many people forget in the second law and say that the force is proportional. It's not the force, people, it's the net force, which is why I'm explaining this in this video. Let's say you have a mass of 10 kg and then I apply like it's let's say it is I apply a force of around 10 newton like 5 newtons, and from this side I apply a force of 4 newtons. I take this side as positive, right? And this side is negative. Now the net force is called the summation of the forces, which means in this case if you add 5 plus plus minus 4, it's not just 4 guys, it's minus 4, then the net force is going to turn out to be 1 newtons, right? Now I'll give you another case. Let's say I apply another force of 6 newtons in this way, and I'm taking this side as positive. So the net force will be 5 plus 6, that is 11 newtons, right? These are the things you need to understand before actually proceeding to the derivation of the second law, right? So here we can say that the net force, right? Let's say there's an object, right? There's an object. Wait, just a minute. There's an object. I'll draw a line here. Uh-oh. I'll draw a line here. Let's say there's an object with mass m and is moving with an initial velocity of u. So initial velocity will be momentum will be mu because it's mass into velocity and it's mu. Now I apply some force, and you know very well that when you apply some force, the velocity is going to start changing, right? So let's say it reaches a place here after force is applied, same mass, right? Mass doesn't change as a scalar quantity only for these objects except rocket. We're not talking about rocket here. So the P final is gonna be MV, sorry, MV, right? Now I just told you that the change in momentum is called is called delta is called change, right? So of course here change will be the final momentum minus initial momentum. This is logic, correct? Over time, right? Now F net, okay, F net. So okay, fine, just leave it. F net is proportional to mv minus mu, correct? We just saw that, minus mu over t, correct? Which means that I can take mass common here and say that F net is proportional to, if you take m out, it's going to be v minus u upon t, right? Is proportional to m into v minus u upon t. And we learned in the first chapter of motion that v minus u upon t is nothing but acceleration, right? It's going to be acceleration. So now we can say F net from this equation is proportional to mass into acceleration. Now, to break this proportionality sign and satisfy the SI unit of force, that is Newton, we assume that the constant is going to be 1. So, is equal to kma, and here k is at 1. So, 1 into ma is ma, right? Now, the mass SI unit is m, and now SI unit of acceleration is meter per second square. Now, you would be like SI unit of force is meter per second, kg meter per second square, but Newton has worked and done a lot of contribution towards this field, and hence we tell the SI unit of force as newtons. In CGS system, it's going to be gram centimeter per second square, and this, my dear friends, we call as dyne, right? The spelling is DYNE, right? Now, force, right? It has two formulas. It's not just MA. You can also say that it's also equal to the delta t, p by t, right? Both are same. Delta p by t is equal to ma, right? It's same thing. Now you tell me, people, right? The second law is actually giving us the information that when you are applying a force on the object, what changes does the object face, right? Also, from here we can say, when we say F equals to ma, right? Mass is inversely proportional to acceleration, right? So mass increases, acceleration will decrease, acceleration, right? Mass increases, acceleration will decrease, right? We can say also that force is proportional to mass, as well as force is proportional to the acceleration, right? These are the deduced facts which we've got after the derivation of the second law of motion. So the equation, the most important equation is F net. F net, not just force, people. F net is equal to ma. So this is the second law, my friends. Thank you for watching this video. I hope this helped you, right? Thank you.